Good morning, everybody. Today we are going to talk about positional astronomy. First, what is astronomy? Astronomy deals with the object in the sky, that is the sun, the moon, the stars, and the planets and the other objects. Now, sun has direct influence on everything on Earth. In fact, without the life, in fact, life on Earth would not have been evolved without the mercy of sun. And the tidal effects of the moon in the coastal areas also affect the life of human beings. But the stars and planets in the sky do not have direct influence on human life. But the study of motion of the planets and the stars were studied from ancient times by the astronomers. The case was same for all over the world. The Greeks, the Egyptians, Indians, the Chinese, all studied astronomical objects, especially planets and stars and constellations. Now, what is the reason behind this thing? Basically, there are two reasons. One is due to the knowledge of the season which is needed for the cultivation. And the other reason is for religious rituals. Still today, many religious festivals are being observed by the phases of the moon. Say, for example, the favorite festival of Bengal, Durga Puja, starts with new moon and ends in the 10th day of the moon. So many religious rituals are observed according to moon phase. Now, my question is actually, this question is to students: why religion has adopted this concept? Why they think it important to study the motion of the planets and the stars in the sky? Next, move on to as the our common sense and logic developed, one thing is changed in this whole history of astronomy. That is, in previous years or previous ages, the universe was considered to be Earth central. That is, Earth is in the middle of the universe and everything rotates around Earth. That concept has changed by the careful study of Tycho Brahe, Johannes Kepler, Copernicus, and finally Galileo Galilei. Copernican model was that the sun is the center of the universe, and if we assume this thing, then the motion of the planets can be described very accurately. Now we know modern astronomy deals with the fundamental of physics. That is understanding of physics, basic physics, quantum mechanics, gravitation, relativity, statistical mechanics, heat and thermodynamics. Everything is needed to understand what is happening in the celestial bodies. That is, what is happening inside a star, inside a white dwarf, inside a neutron star, inside a galaxy, in quasars, everything. To understand what is happening in these objects, we need to understand basic physics. So physics is now interrelated with the astronomy. Astronomy has a key role in developing scientific model of the observed universe. Now, To be precise or to be quantitative, you have to measure the things that we have to estimate. Three basic things in physics are there: distance, mass, and time. Now, the distance of the astronomical objects are very huge compared to the distance that we perceive in everyday life. For example, the nearest celestial object, Moon, is at a distance of 60 R, where R is the radius of the Earth. From Earth. Planets are nearer to us. The nearest planet to Earth is Venus, then Mars, Mercury, Jupiter, Saturn, and all this. In the study material I have given to you, there is a table of the planets stating their distance from Earth. Stars are far apart from us. For example, the nearest star, which is Alpha Centauri. Alpha Centauri means it is in the constellation of Centauri, and it is denoted by the letter alpha, means it is a very moderate brightness star. Its distance is 4 light years. Distance of Alpha Centauri, 4.5 light years. 4.5 light years. Now, our galaxy, the Milky Way galaxy, the center to our galaxy is at a distance of approximately center to galaxy approximately 25,000 light years. The nearest galaxy, that means other galaxy than our host galaxy Milky Way, Magellanic Cloud, is at a distance of 1.5 lakhs light years. And the most distant object observed so far is the quasars, which are billion light years. Billion light years. So they are very distant. In fact, when the light from this distant object started its journey towards Earth, probably Earth has not evolved there. Next, we have to consider the distance, the mass. Mass of the Sun, which is a moderate star, is of the order of 1.99 into 10 to the power 30 kg. It is denoted by m naught. Mass of the Sun. It is a moderate star. Mass of the planets are very small. Planets mass of the Earth, say, mass of Earth is much less than m0, and so also the other planets. Mass of the stars has a range. Mass of the stars that we observe in night sky has a range from 0.1 to 60 solar mass. Now, why this range? Let me explain a little bit. We know that stars are glowing objects. Nuclear fission is happening inside the stars. Now, for masses less than 0.1 solar mass star, the core temperature is not high enough to ignite nuclear fission. So this is to be a star. There may be a planet or a brown star or something else. And for stars with heavy mass, the core temperature is very high, so that the nuclear fusion rate is very first, so that its fuel means the hydrogen is used up very quickly. Within few million years of its birth, this star will exhaust its fuel. So we will not observe it today. That is the reason. Generally, the stars that we observe is in their mass range. Now, the mass of a galaxy is 10 to the power 40 to 10 to the power 43 kg. The mass of the galaxy of a typical galaxy is order of 10 to the power 40, 10 to the power 43 kg. That means 10 to the power 10 to 10 to the power 13 times the mass of the solar mass. So we can assume that in a galaxy there are 10 to the power 10 to the power typically 10 to the power 10 number of stars. The mass of the whole universe is estimated to be 10 to the power 55. So the mass range is tremendously high. Now, to consider the age of the universe, age of the objects that we see, astronomical objects, the age of the universe is assumed to be 13.6 billions. The present day knowledge of the universe is that the universe has been created in a big bang, a huge explosion, and after that it is expanding. That big bang occurred at a time 13.6 billion years ago. The age of our sun is 5 billion years, and it is estimated that our sun will glow for another 5 billion years. Life on Earth is about 3.5 billion years old, though the mammals in Earth came very later time. So these are about distance, mass, and time scales. This is a huge scale. Now we will move on to the basic concept of positional astronomy. The sky that we see in the night or in the day is a half hemisphere, right? It is a sphere divided by the horizon. We see the upward portion and the below portion is below the horizon. Now to locate an object, astronomical object in the night sky, though the stars and the planets are distance distance of these planets and stars are not same, but it appears that, or it will be very convenient to suppose that all the celestial objects lie in a large sphere. We call it celestial sphere. And as Earth is rotating about its axis in 24 hours, the sky the sky appears to be rotating with same time period from east to west, because the Earth is rotating from west to east. Now, as it is rotating, there must be a pole. Presently, the axis about which the sky is rotating or the Earth is rotating is the pole star. We call it pole star. So here I am showing you. Say this is celestial sphere. This is celestial sphere. The celestial sphere. See, this is your zenith, means the point just above your head. This is the horizon. And say this is the north celestial pole. This is the origin of the sphere, that is where the observer is situated. Then this great circle is called celestial equator. And this is horizon. This is horizon. And this is j. You know, this is the latitude lambda, where the observer is observing the sky. Now, to locate the position of a star or a planet or anything in any celestial object in the celestial sphere, we need two coordinates because it is in the two dimension. Generally, two coordinate systems are used. One is equatorial coordinate system, and another is horizontal or geographic coordinate system. Now, geographic coordinate system, you know, it's very easy. Two coordinates are latitude and longitude. And equatorial coordinate system, the coordinates are generally taken as declination and right axis. We'll discuss later about the declination, right axis, latitude and longitude. Now, in an observer is often needed to transfer the coordinates from celestial equatorial coordinate system to geographical or horizontal coordinate system. To know the transformation, we need to study a little bit of spherical geometry. So now we are discussing about spherical geometry. Okay, this is a sphere. Now, a great circle divides the sphere into two equal halves. So this is a great circle. And any other circle is called small circle. So this is small circle and this is great circle. Now what is special about great circle is that the distance between 2 points on a spherical surface will be minimum if we draw a great circle between these 2 points. In other words, between 2 points, a great circle can be drawn always, provided that 2 points are not antipodal points. So what are antipodal points? Will be clear in the course of discussion. For the time being, it is very important to know that the distance between 2 points on a spherical surface is minimum when we pass from one to other with a great circle. Now, great circles intersect each other. So, spherical triangle is created by intersection of this great circle. Now, let us investigate the property of spherical triangle. Suppose we are discussing spherical triangle. This is one gate circle. Say this is another gate circle. This is another gate circle. Then these 3 points A, say B, and C. This is called ABC is called spherical triangle. Now, peculiarity of spherical triangle compared to the triangle we generally observe in 2 dimensions is that the angle between these, the sum of the angles say A plus B plus C is always greater than 180 degree or 5 degree. 5 degree. Now, a quantity excess of angle is defined, which is excess of angle is defined, which is equals to A plus B plus C minus 1. Now, area of the triangle has this form. Area of the triangle E into R square if R is the radius of the sphere. Now to prove it, how to prove it? To prove it, let us complete the great circles other way around. Say this is a great circle, we are completing other way around. This is another great circle. This is another great circle. So see another triangle A dash, B dash, C dash. So another triangle A dash, B dash, C dash is created, which is congruent to triangle ABC. This triangle A dash, B dash, C dash is congruent ABC. In fact, if you see, A dash point is just antipodal point of A. That means if A is a pole, then it's A is north pole, then A dash is south pole. Similarly, if B is north pole, then B dash is south pole. So, from similarity or from symmetry, we can say that triangle A dash, B dash, C dash is congruent to triangle ABC. Therefore, the area of triangle A dash, B dash, C dash will be equal to the triangle ABC. Now, to find the area of the triangle, let us consider the strip. Consider the strip from A to A dash, this way down. Consider this strip. This strip has an area 4 pi r square into angle A, and total angle is 2 pi. So this comes out to be 2a r square. So area of the strip from A to A dash is 2a r square. Similarly, angle between A and A dash other way round, that means this way round, is also 2a square. So area of the strip, A dash, both way round. both ways is 4a aspect. Now, if we perform the same operation, say along BA, if we extend BA and BC, then we get a portion B, B dash, get a strip B, B dash, and another is C, C dash. In this way, if we consider these three strips, then the whole area of the sphere is covered, and this area ABC and the area A dash B dash C dash is taken 2 times XS each. That means area ABC is taken 2 times XS and the area A dash B dash C dash is taken 2 times XS. So the equation becomes 4 into A plus B plus C into R square. This is the area of three strips. This must be equals to 4 pi R square, which is the area of the sphere, plus 4 times the area of the triangle ABC. From where you can see that delta ABC equals to A plus B plus C minus pi. You know what is this? This is axis angle, so E R square. So area of a spherical triangle is E R square. Next, we have to consider the trigonometry or the relations between the exterior angles and interior angles of a spherical triangle. Now, what are the interior angles? Let me draw it again. What are the interior angles? Suppose this is a sphere. This is one great circle. This is another great circle. This is another great circle. This is A. This is B. This is C. Say this is the center. Let us join it. Then this angle is small a, this angle is small b, this angle is small c, such that if r is the radius, then this relation holds. Arc AB will be equals to r into c, and BC will be equals to r into a, and AC or CO will be equals to r into b. So these are the inner angles and relation between inner angles and outer angles. Next, we have to consider the transformation of coordinates. If we transform coordinates, then the transformation relation will give you the coordinates relation between the coordinates. But that will be discussed in the next class. For the time being, we are finished here. I will suggest you to go through the notes that I have provided, and if you have any question regarding this, then you can consult me in the WhatsApp group or in mobile. So thank you. We'll meet in the next session.